Hello and welcome back. Today we're going to be discussing the topic of disc brakes. I'm going to start with a quick review of disc brake calipers. This type is a floating caliper. It's called a floating caliper because of these slide pins that run alongside of the caliper body and anchor it to the caliper mounting bracket. The caliper mounting bracket has been removed from this application. These slide pins allow the caliper to float or slide back and forth, and as that inside pad is applied against the inside of the rotor from the piston, it's going to allow the caliper body to slide and float against those slide pins and engage the outer pad. Once the pressure is released, this goes back out and we don't have contact or pad wear with our brakes. This is a two-piston example of another floating caliper. This example is equipped with the caliper mounting bracket. This is what would be considered a loaded caliper. It has friction material. Both pads are inside, held in place by the caliper mounting bracket, and the caliper body mounts to the bracket right here and right here. These are our slide pins. This operates the same way as a single piston, but with two pistons. Fixed calipers will always have an even number of pistons. The fluid pressure has to apply the pistons on both sides of the rotor, so that fluid passes through the two halves that are fastened together across this machine surface and distributes evenly around the brake rotor. These are the heaviest and they are the most prone to leaks. Since we have this seal that the fluid has to pass through, we can develop leaks in the actual body itself. However, since these are so heavy and stout, there is a lot of material to dissipate heat through. So these will offer a higher performance braking and can dissipate heat more effectively.
This isn't a very clear example, but this is an example of a sliding caliper, where we don't have slide pins, but we do have shims and ways that the caliper moves back and forth across, much like it would on slide pins on a floating caliper design. This locking fastener retains the slide piece that keeps tension on the caliper body against the bracket, or against the way. You can see the upper part of the body makes direct contact from the body to the bracket, or to the way.
The overall function of disc brakes is a caliper body is going to squeeze friction material on two sides of a rotor. So the rotor has two friction surfaces, one on this side and one on the back side. So as the rotor is turning, those pads will squeeze together and stop or slow the rotation of the rotor down. Pressure is applied to the system and the pads are clamped around the rotor. The stopping force is very consistent from one side to the other side. This makes them ideal for use on the front of vehicles to avoid having any brake pull when slowing or stopping a vehicle. Another advantage they have over drum brakes is that everything is exposed to the open air. So this can dissipate heat much more effectively, resulting in less problems with brake fade. Now, if you recall, there are 4 types of brake fade. There's mechanical fade, which on a drum brake assembly is when the drum expands away from the friction linings on the shoes. When the rotor expands, it expands, but it's surrounded by the friction material of the pad, so it actually expands into the friction surface. So mechanical fade is not as much of a concern on disc brakes. Lining fade occurs when the friction material is heated to the point where the coefficient of friction starts to drop. Since disc brakes are open to the environment, their heat is dissipated much more effectively, making them less prone to lining fade. Gas fade occurs when enough heat is generated on the friction surface of the pad that the compounds of the pad start emitting a gas. That gas gets trapped in between the friction surface of the friction lining, or the pad, and the friction surface, in this case the rotor. When that happens, that gas layer doesn't allow those two surfaces to touch each other and provide adequate stopping force. Instead, it acts as a lubricant, almost like an air hockey table with a puck, and lets it glide across. Disc brakes being open to the environment again make them less prone to building up heat and trapping gas in between the pad and the rotor, so they are less susceptible to gas fade. Water fade occurs when water or other contaminants can get in between the pad and the friction surface of the rotor. Unlike drum brakes that are contained within the drum, the pads almost act like a squeegee and help wipe away any of the surface contaminants that may get onto a rotor, so they are less susceptible to water fade as well. Some disadvantages to disc brakes are that they don't have self-energizing action. I've heard of some of this technology on the horizon, but I have not seen it implemented in production vehicles. Unlike drums that use the rotation of the drum to help wedge friction material into the surface, all these are doing is clamping on a flat surface. There's no self-energizing action to help them apply harder and use that rotation to develop more stopping force. So they require more force to establish a fixed level of stopping power. Disc brakes are also more susceptible to types of brake noise. Brake noise can occur from contaminants or surface imperfections on the surface of the rotor. It could be due to anti-rattle clips not working properly or missing. Moving components of the caliper may get worn out over time and develop a chatter or a vibration. Most brake noise is going to be noticed as a rattle or a squeak or squeal. The squeaks and squeals are very small vibrations that resonate at a high frequency. Some things that contribute to brake noise can be surface rust on the brake rotor itself. Once the vehicle is parked, this exposed polished steel surface may develop surface rust. And most of the time that surface rust is cleaned up within the first few stops the next time the vehicle is driven, during which time there may be some squeaks or some brake noise coming from that surface. If a vehicle is left unattended for a long period of time, that rust can wear deeper down into the surface and become permanent damage to the rotor surface. Other sources of brake noise can come from the anti-rattle clips, or the pad contact with the surface, or the slide pins. If any of these are not moving smoothly and are not clean, they may contribute to brake noise as well. Since disc brakes by design don't offer any self-energizing action, it makes them less ideal for a parking brake. In fact, some rotors will be designed with a drum brake in this portion of the rotor. Those are referred to as top hat rotors. Imagine a top hat. Wide brim, tall top. Inside that top hat may be a small dedicated drum brake assembly specific to the operation of a parking brake. Otherwise, parking brakes have to be incorporated into the design of the caliper to help mechanically apply or electronically apply the brakes at that wheel. To help protect the brakes on a disc brake system, there is often a splash shield that surrounds the inside portion of the rotor that's exposed to the underside of the vehicle. There will be a cutout to allow for the mounting of the caliper assembly in the bracket. The dust or splash shield is a thin gauge sheet metal piece that's stamped to help protect the inside. Now this protects the rotor and the brakes from any debris and can deter water and dust and dirt and mud from potentially contaminating the surface of the rotor. They can contribute to brake noise by either being bent and contacting the rotating surface of the rotor. They can rattle if they are cracked. They can also trap little things like pebbles or little chunks of debris. If they bounce up from the road surface and find their way in between the splash shield and the rotor, they will often make a squeaking noise. The dust shield or the splash shield will often be mounted to the steering knuckle itself or the spindle assembly. Rotor design will vary depending on the application that they're made for. Some rotors may be solid. Like in this case, this rotor is solid. There's no gap in the middle between friction surfaces. Other rotors may have venting in between. This gives the rotor more ability to dissipate heat. Rotors provide the friction surface for the brake pads. They are usually the largest and the heaviest component of the disc brakes, and most commonly they're going to be made out of cast iron. You may come across some that are made of different composites. Rotors may also be slotted or cross-drilled to aid in cooling as well. Slots will actually be grooves in the surface that trap pockets of air and rotate that trapped air across the friction surface of the pad as the rotor turns and the pad is applied. Cross drilling are holes that are drilled across the face of the rotor, again helping to cool the friction material during operation of the brakes. One example of that is a carbon ceramic rotor found on the 2017-2018 Corvette Z06. They're made out of carbon ceramic. They're lightweight, they are brittle, they can't be machined, but they offer an optimum braking performance for the vehicle. Last I checked, to replace one of those rotors, it was $625 each. Not only is their cost expensive, but they are susceptible to damage on shock or impact. They can crack more easily than a cast iron, but they offer optimum brake performance. Let's go through the construction and components of a typical disc brake assembly. Removal of our caliper mounting bolts. The caliper body can be removed from the caliper bracket and the pads. This would normally have a brake hose attached to it, and this should never hang from the hose. Always support these by hanging them by a hook or a bungee to the chassis or suspension components. Here, our mounting bracket is holding the pads. This is our outer pad. And our inner pad. On each end of the caliper bracket are the anti-rattle clips. Mounted to the caliper mounting bracket are our slide pins. Here's the upper. And the lower. The caliper mounting bracket can be removed from the spindle assembly by removal of these two bolts. This is our caliper mounting bracket, without any slide pins, dust boots, anti-rattle clips, or hardware attached to it. With the caliper disassembled, we can look at some of the more individual components. The anti-rattle clips help reduce vibration and rattles coming from the pads where they mount on the caliper mount bracket. These allow for smooth, quiet operation of the brake pads while keeping tension on them and allowing them to move. The brake pads are the friction material. There is a soft friction material bedded onto a steel backing. Some of these will have additional shims on the back to help in insulating some of that noise, those vibrations. This one has a wear indicator in the form of a scratcher that will contact the rotor surface before the pad wears and reaches the backing plate. The brake pads may have grooves cut into the profile of them to aid in cooling and noise dampening. Also with chamfering the ends, so they may be tapered like that, also to help reduce noise. The backing plate may have tabs that need to be bent onto the caliper to help keep it in place. That's more common on older assemblies. Another type of wear indicator may be an electrode. So there may be a electrical piece that installs into the pad at some location with a wire coming out of it. So when the pad thickness wears down and that electrode contacts the rotor surface, closes the circuit and gives a command to the control module to inform the driver that the pad is low. This is a single piston floating caliper design. And notice we have a window here. This window allows us to see a portion of the inside pad without removing the caliper. When we're inspecting disc brakes for wear, we're looking for a few things. There are a few indicators that can point to certain faults in a caliper design. If we have even and consistent wear across both brake pads, that's optimal and does not indicate any problems with the system. If that even wear was on one side and on the other side we had little to no wear, that may indicate that one caliper is not providing enough stopping force on one side. That could be due to air in the system, that could be due to a seized caliper piston, or caliper slide pins. If our pad wear was tapered, where it was worn more on one side than the other side, then we can suspect that during application of the brakes, the caliper may be twisting during application of the brakes. As that twisting motion occurs, that could be caused by slide pins. If one pad is worn more than another pad, then something may be sticking on the caliper and not allowing it to either move and apply the outside pad, or it may be stuck in the applied position, keeping pressure on the inside pad. When servicing disc brakes, there are key steps to pay attention to when servicing, cleaning, and reassembling. I'm going to mount the anti-rattle clips back onto our caliper mounting bracket, and making sure that all the little tabs are routed where they need to go. If something was in the way, possibly of the rotor could drag against one of these tabs, so make sure they fit properly. Applying high temperature grease to the anti-rattle clips helps the pads move smoothly and effectively. Also taking care not to put so much on there that it gets onto the friction material. Any excess lubricant should be wiped off. Depending on your application, it may be easier to put the pads on the bracket before mounting the bracket back onto the vehicle. When installing pads with wear indicators like this scratcher type, if it's only on one pad per side, it should go on the inside pad, because that side is hardest to see on a visual inspection of the brake system. The inside pad is going to be the one that mounts to the same side as the mounting flange of the mounting bracket. When mounting pads to the mounting bracket, take care not to get any lubricant onto the pad material itself. Following service information, they may require you to put an additive on the back of the brake pads. Typically, if it doesn't specify in service information, we'll apply some brake grease to the backside. This grease will reduce vibrations and help insulate any of those noises. If the vehicle you're working on has a floating rotor, meaning it's held on by the wheel studs and the lug nuts and is sandwiched in between the wheel and the hub, then it may be loose without the wheel on there. Putting some lug nuts on and some spacers or washers helps keep everything nice and tight and not moving around too much while you're trying to reassemble. Always torque your fasteners to manufacturer's specifications. Once your caliper mounting bracket has been installed and your pads and anti-rattle clips have been installed and everything is lubricated, it's a good idea to press all this together against the rotor at this time. This gives us the best chance to fit our caliper over the pads. Before we can mount the caliper back to the assembly, the piston has to be pushed back into the caliper body. Using the appropriate tool, Push the caliper piston back into the caliper and relieve that hydraulic fluid out of the bleeder. Once the piston is fully retracted into the caliper assembly, give it one final inspection to make sure that there are no tears in the dust boot or indications of fluid leaking from the caliper. If everything looks good, it can be mounted to the caliper bracket. Before we can mount the caliper back to the caliper bracket, we need to reinstall our slide pins. They need to be cleaned of any contaminants or grease from disassembly, and then once they are clean and dry, apply new grease to the slide pins upon reassembly. Now the caliper can be mounted back to the assembly. Once our caliper is in position, attach our mounting hardware that fastens it to the caliper slide pins. And as always, tighten with the torque wrench to the manufacturer's specification. Once the brake system service is complete and the fluid level is at the correct level and all other tasks have been performed in the system, it's time to take the vehicle on a final test drive. I want to talk a little bit about the 3 C's. The 3 C's stand for concern, cause, and correction. A customer will come into a service shop with a concern. Based off of their concern, the technician has to duplicate that concern to find the root of what is causing that concern. Once the cause is found and all of their inspections are done, then the technician can perform the correction to the cause in the form of a service or a repair to the system. When addressing any system, it's best to address the entire system rather than just the component that failed or the area that needs attention. The whole system should be inspected to determine what the overall health of the system is, so it can be serviced or repaired accordingly. Some of the symptoms from disc brakes that customers will have concerns with are going to be, for the most part, noise, inadequate braking ability, vibrations, or shimmy. They may feel the vibrations in the vehicle, in the brake pedal, or in the steering wheel. Depending on how these symptoms occur, the technician has to identify them on a test drive. Once the service and repair is complete, the vehicle needs to be test driven to make sure that there are no other issues or that the correct issue has been addressed and that the customer's concern has been addressed. There are a few more things to cover on disc brakes and on drum brakes that pertain more to the machining and the measuring of those components. So we'll get into that next. For now, this has been Disc Brakes. Thank you.